Okay, so we're gonna go through the trends of the periodic table. So the first one that we're gonna look at is the period. So your period are gonna be your horizontal rows. So periods are gonna go from left to right. And at least on this periodic table, but even if you count them down, you'll have these numbers on the side. Got a little cut off from the printer, but those are gonna be your period numbers, and they're gonna show you the number of energy levels that you have. So this one is 1. You're gonna have 1 energy level. So all of these elements are gonna have 1 energy level, basically 1 ring in the Bohr's model. Then you have 2, goes there, 3, 4, 5, 6, 7, and then these 2 are part of 6 and 7 as well, because they just kind of plug in right there. So periods is going to be very simple. As you go across the table and you move across the period, your elements are going to start becoming more different from one another. So here we have potassium. Potassium, as you move through the periodic table to bromine, your characteristics are going to start changing, even though they're in the same period. So now we have, let's talk about groups. So groups are going to move up and down the rows, or the columns, I mean, groups up and down. Okay. So, like, it doesn't show it on this table, but because this is just showing all the columns as you move across, there is, it's going to be like 1A, or 2A, 3A, 4A, 5A, 6A, 7A, and then 8A. And basically these are the group numbers, and they're going to tell you the number of valence electrons. So everything in 7A is going to have 7 valence electrons. And they're going to share other similar properties, but the big thing is, and the easiest thing that you can use looking at it, is the number of valence electrons. So it'll help you with making like your Bohr's model. It'll help you determine the electronegativity, the reactability, all of that. Okay, so yeah, just leave it over. Sorry, I had a student walk in. Okay, so let's talk metals. So I have my colored pencils. You don't have to label yours, but if you printed it in color, it should already like show you what each thing is. So metals are going to lose an electron, and that's going to make them positive, a positive ion, and that'll make them a cation. Okay, so your metals are going to basically go from the start all the way to right here. These are all going to be metals. So I'm just going to lightly shade them so you get an idea. Ooh, this is not a very good color, or what is this, a crayon, but you get the point. So these are all metals. In the notes, it mentions something about an alloy. An alloy is just when you mix metals by melting them together. So metals are going to have a low ionization energy and low electron negativity. They're good conductors of heat and electricity, and that's why most of your pans are going to be, like your kitchen pans, are electric, or what is it, metals. They exhibit a metallic luster, so aluminum, very shiny. The other metals, they tend to have this nice sheen to them. They're easy to be like molded, so they're easily malleable. They can be pulled into wires, so if you've ever had your iPhone charger kind of like fray on you and you can see the inside of it, that's all metal. Most of the periodic table is metal from the shading that we just did. They have high densities. There is a special characteristic of mercury where it's the only metal that's going to be liquid at room temperature, and your most reactive metal is going to be francium, found in the bottom left. So the bottom left is going to have francium, and that's going to be the most active and reactive metal. Okay, so let's talk about non-metals. So non-metals are going to be on this side of the table, so definitely the other side.
Thank you.
Mm-hmm.
Awesome.
Sorry about all the distraction.